Assalamualaikum doctor, and a very good day to you. My name is Ahmad Bukhari, student ID 906965. Today inshallah I will be presenting to you my assignment 2, data analysis using SmartPLS. For today, this will be the agenda of the presentation. The agenda actually covers the requirement that is requested and outlined in the assignment 2 question that was provided to all students. Now moving on to the first item in the agenda, which I will be covering, which is the indicator reliability loading AVE. Now first, it's important for us to understand what actually is an indicator reliability. So indicator reliability, also known as loading or factor loading, in the context of factor analysis, is actually a measure that shows the correlation between the observed variable, also known as indicator, and the latent variable, which is known as factor it is supposed to measure. Now each item loading shows the proportion of the variance in that item explained by the factor. Loading are typically expressed as correlation ranging from -1 to +1, with higher absolute value indicating stronger relationship with the latent variable. A high loading, example 0.7 or above, is an indicator of a strong relationship between the latent and observed variables, which in turn signifies good reliability. Now, when referring to AVE, or also known as average variance extracted, this is a measure of the amount of variance that is captured by the construct in relation to the amount of variance due to measurement error. It is generally considered that an AVE of 0.5 or above indicates good convergent validity. Now, the reason for assessing loadings and AVE is to actually evaluate the validity and the reliability of the construct in the model. So there are a couple of reasons. Number one, reliability. High factor loading means that the observed variable relates strongly to their respective latent variable. Now, this indicates that the measures are reliable as they consistently represent their intended construct. Second reason is convergent validity. When factor loadings and the AVE are high, it indicates that the items of a construct are highly interrelated, demonstrating convergent validity. And finally, discriminant validity. Checking loadings and AVE can also contribute to understanding discriminant validity. If an item loads significantly higher on the factor, it is supposed to measure that on the other factors. It suggests good discriminant validity. Now, in summary, checking loading and the AVE is a crucial part of validating a measurement model in structural equation modeling and also multivariate analysis. And this is to ensure that the constructs are reliable and valid. Now, if we look into the assignment, this is the outcome of the indicator reliability analysis. And what can be found from this table is, number one, composite reliability. The composite reliability coefficient, row A and row C, assess the overall reliability of the construct. The range for row A value is between 0.778 and 0.903, and for row C, values is between 0.82 and 0.911. Now, this means that both are indicating high shared variance among indicators and hence a strong reliability of the construct. Second, average variance extracted, or AVE. The AVE value ranges between 0.463 to 0.773. Now, this illustrates that the variance captured by each construct compared to the measurement error. The result indicate that a considerable portion of variance in the construct is accounted for by their corresponding indicators. Third, high Cronbach alpha coefficient. The high Cronbach alpha coefficient ranging from 0.720 to 0.854 suggests robust internal consistency within the construct. thereby supporting the overall reliability of the construct. Now, what we can conclude from this analysis is that the result from the study suggests the measurement model used exhibits good reliability. The internal consistency is strong, as indicated by the high Cronbach alpha coefficient and composite reliability value. The AVE value highlight that the construct variance is significantly explained by their corresponding indicator, further strengthening the reliability of the model. Now moving on to the next slide. Now, endogenous variable variance. Now when we talk about variance of an endogenous variable, we are actually referring to how much the value of that variable spread out from their mean. Variance is a statistical measure of the spread between numbers in the data distribution. Now it measures how far each number in the set is from the mean, thus from every other number in the set. It is often denoted by the symbol of sigma powered by 2. Now, in the context of a model, the variance of an endogenous variable can help us understand the extent to which the variable can change as a result of changes in the exogenous variable. In the variance of an endogenous variable is high, it means that the variable can take on a wide range of value depending on state of exogenous variable. This could suggest that the model is highly sensitive to changes in input. If the variance is low, it suggests that the variable is relatively stable and doesn't change much in response to changes in the input. Now, in terms of model performance and predictive accuracy, a high variance could indicate overfitting, where the model is overly sensitive to the training data and may not perform well on new unseen data. A low variance could indicate underfitting, where the model is not sensitive enough to the training data and may not capture important patterns or relationship. Now, this concept of variance of an endogenous variable is fundamental in many different types of analysis, which includes regression analysis, path analysis, structural equation modeling, and many machine learning algorithms. Now, it can help us understand the dynamics of the system or model being studied, assess the performance and predictive accuracy of the model. Now, if we look at the analysis done when it comes to endogenous variable variance, there are two tables here that is shown. First is the coefficient of determination R square. The second one is F square. Now, if we look at the results from both tables, the results from the R square table shows that satisfaction explains 31.2% of R square. It is of the variance in student loyalty. And when accounting for the number of predictor, the adjusted R square is 27.6. Now, this suggests that the satisfaction has moderate impact on student loyalty. Now, from the F square table, the value indicates that empathy has the strongest influence on satisfaction, followed by tangibility, reliability, responsiveness, and assurance, all relatively weaker impact. Now, in conclusion, from these two tables, enhancing satisfaction, particularly through empathy and tangibility, can actually positively impact student loyalty in education institution. Now, moving on to the next slide. Now let's talk about inner model path coefficient sizes. The inner model path coefficient, when it is being done in SmartPLS, actually refer to the strength and direction of the relationship between construct in a structural equation model. Now, each path coefficient is a standardized estimate that quantifies the direct effect of one construct on another. Now, the size of the path of the coefficient indicates the strength of the relationship between two constructs. The larger the absolute value signifies a stronger relationship, while a smaller absolute value indicates a weaker relationship. The sign of the path coefficient, whether it's positive or negative, indicates the direction of the relationship between the two constructs. When we see a positive coefficient, it suggests that an increase in the predictor construct is associated with an increase in the outcome construct. and when we see a negative coefficient, suggests that an increase in the predictor construct is associated with a decrease in the outcome construct. Now, the significance of the path coefficient is usually determined by conducting either a bootstrap resampling procedure, which generates a t-value for each path. If the t-value exceeds a certain threshold, for example, let's say 1.96 for a significant level of 0.05, the path is considered statistically significant. Now, looking at the outcome of the analysis for this assignment, when it comes to the inner model path coefficient sizes, the result of the inner model path shows that the relationship between different variables in the model. The path coefficient represents the strength, as mentioned previously, and the direction of the relationship. Now, again, if we look at the table, the path coefficient between assurance and satisfaction is 0.132, revealing a positive but relatively weak relationship. This indicates that when customers perceive a higher level of assurance in a service, it has small positive impact on their satisfaction. The path coefficient between reliability and satisfaction is 0.814. Now, this shows positive relationship, but again, a weaker than one between empathy and satisfaction. Now, this suggests that a higher perception of reliability in a service contributes to a moderate increase in customer satisfaction. The path coefficient between responsiveness and satisfaction is negative 0.16, indicating a negative relationship. This suggests that when a customer perceives higher responsiveness in service, it has small negative impact on their satisfaction. The path coefficient between satisfaction and student loyalty is 0.578, indicating quite a strong positive relationship. Now, this implies that higher satisfaction level lead to greater student loyalty. The path coefficient between tangibility and satisfaction is 0.231. Now, this indicates a positive relationship. Now, this suggests that when a customer perceives higher tangibility in a service, it contributes to a moderate increase in their satisfaction. Now, in conclusion, from this table and the results, the model demonstrates the varying degree of impact that different factors have on customer satisfaction and student loyalty. Assurance and reliability have relatively weaker effect, while empathy and tangibility have moderate effect. The unexpected negative relationship between responsiveness and satisfaction requires further investigation to understand the underlying dynamic. Overall, satisfaction plays a crucial role in driving student loyalty, with a strong positive relationship observed between the two. Now, these findings emphasize the importance of focusing on empathy, tangibility, and satisfaction to enhance student loyalty and improve overall service experience. Now, let's move on to the next slide. Now, outer model weight. So, what is it actually is outer model weight? Now, outer model weight, also known as outer loading, represents the importance of each indicator or observed variable to their respective latent variable or construct in the model. In other words, these weights tells us how much indicator contributes to the definition of the construct. Now, how do we interpret these weights? First, if the outer model weight of an indicator is large and statistically significant, this suggests that the indicator is important in defining the construct. However, if the outer weight is small and not statistically significant, this means that the indicator does not contribute to the definition of the construct. Now, it is important to note that removing indicators with non-significant outer weight should be done in a very cautious manner. In many cases, an indicator might have a small outer weight but could still theoretically be important to the overall construct. Now, looking at the outcome of the analysis for this assignment when it comes to the outer model weight, the results from this table provide information about outer model weight and their significance. For assurance, the outer weight range from 0.239 to 0.35, indicating moderate relative strong relationship with its indicators such as ASSU1, ASSU2, ASSU3, and ASSU4. Now, this suggests that this indicator effectively captures the construct of assurance Empathy also shows moderate to strong relationship with its indicator with MPA 1, MPA 2, MPA 3, MPA 4 and MPA 5, with outer weights ranging from 0.223 to 0.37. Now these results indicate that chosen indicators are suitable for measuring empathy. Now let's look at another example. Reliability exhibits a range of outer weight from 0.233 to 0.348 with its indicator REL1 all the way until REL5. Now these values suggest moderate to relatively strong relationship, indicating that selected indicator effectively represent reliability. Responsiveness has outer weight ranging from 0.246 to 0.358 with indicator of RES1 all the way to RES4. This weight indicate moderate to relatively strong relationship that suggests that the indicators adequately capture the construct of responsiveness. Now, I will not go through each, but I hope the example that I've shared gives a very clear indication of how the outer model weight actually impacts an analysis. Overall, the outer weight model provides evidence of the relationship between the latent construct and their indicator. The significant and substantial weight suggests that indicators are reliable and valid measure of their respective construct. Now, these findings supports the valid of the measurement model and provide confidence in the subsequent analysis. Now, let's move on to the next slide. Now, let's look at collinearity among indicators, or VIF. Now, what is VIF? Now, VIF quantifies actually how much the variance of the estimated regression coefficient is increased due to multicollinearity. The VIF of an independent variable is actually the ratio of the variance of the estimated coefficient of that variable to the variance of the estimated coefficient if that variable were not correlated with the other independent. Now, looking at the outcome of the analysis from this assignment for the collinearity among indicators, or VIF, what are some of the findings? First, collinearity among indicators in a model is assessed again using VIF. The construct of assurance, empathy, and reliability shows moderate level of collinearity with satisfaction, with VIF values of 2.379, 1.847, and 2.173 respectively. Now, this implies that these variables share some variance with satisfaction. Now, if we look at responsiveness, it demonstrates a higher degree of collinearity with satisfaction, with a VIF of 2.857. Now, what this suggests is that responsiveness and satisfaction may share a higher degree of variance, indicating a potential overlap in their measurement. And finally, when we look at satisfaction and student loyalty, satisfaction and tangibility, they have a VIF value of 1, suggesting there is no significant collinearity between these constructs. Now, this indicates no shared variance between these pairs. Yeah? Now, let's move on to the next section, which is discriminant validity cross-loading. Now, in this assignment, there will be 3 discriminant validity that we'll be looking at. First is cross-loading, which will be covered in this slide. Second will be the Fornell and Larker, and the last one will be HTMT. Now let's cover the first one, which is cross-loading. Now, when we talk about cross-loading is actually an indicator or observable variable that is related to multiple latent construct, or unobservable theoretical construct. An indicator should ideally load more highly of the construct it is intended to measure than on the other construct. Now, this loading, also known as factor loading, is the correlation between indicator and factor. Now, when assessing discriminant validity using cross-loading, each indicator's loading on its assigned construct should be higher than its loading on all other constructs. If an indicator loads highly on multiple constructs, it may indicate a lack of discriminant validity, which suggests that the construct may not be as distinct as we originally thought. So let's take an example. Now, if we have a construct of job satisfaction and another construct of job commitment, and if an indicator, let's say I enjoy my work, that is supposed to measure job satisfaction also loads highly on job commitment, it may indicate a lack of discriminant validity between these two constructs. Now, when we look at the table, the outcome table from the assignment, what is the main finding or the key point is that the table in this slide presents the results of cross-loading analysis. Now, this examines the correlation between each indicator and its associated construct compared to the correlation with other construct. The finding shows that the indicator generally have higher correlation with their associated construct compared to other constructs supporting the discriminant validity of the measurement model. Now, in conclusion, both Fornell and Lacker criterion and also cross-loading analysis provide evidence of satisfactory discriminant validity in measurement model. Now, this result suggests that the construct in the model are distinct and reliable measure different aspects of underlying phenomena, allowing the meaningful interpretation of their relationship within this analysis. Now, moving on to the next discriminant validity, which is Fornell and Lacker. Now, again, as a reminder, discriminant validity is the degree to which a construct is truly distinct from the other construct by empirical standards. The Fornell and Lacker criterion is a commonly used test to evaluate the discriminant validity of a measurement model. Now, the Fornell and Lacker criterion suggests that a latent variable's square root of AVE, which is average variance extracted, should be larger than its highest correlation with any latent variable. Now, the AVE is a measure of the amount of variance that a latent construct captures from its indicator relative to the amount due to measurement error. Now, the square root of AVE provides an estimate of the shared variance between the construct and its measure. Now, in correlation metrics, following the Fornell-Lacker criterion, we would see that the number in the diagonal representing each construct correlation with itself are all larger than the number below them, representing the correlation between different constructs. Now, this indicates proper discriminant validity. Now, the discriminant validity of the measurement model can be assessed again through Fornell and Lacker. Now, if we look at this table, it presents that the Fornell and Lacker criterion, which examine the square root of the average variance extracted, AVE, for each construct against correlation between construct. The diagonal value represents the square root of AVE, while the off-diagonal value indicates the correlation between the construct. Now, the finding shows that the square root of AVE, which is the diagonal value for all constructs, are higher than the correlation with other construct of diagonal value. This indicates satisfactory discriminant validity as each construct has greater amount of variance explained by its own indicator and the shared variance with other construct. Now, moving on to the next discriminant validity, which is HTMT, and this will be the final slide. Now, what actually is discriminant validity HTMT? It is actually known as the heterotrait and monotrait ratio, or also HTMT. It is a measure of discriminant validity which is used to evaluate the extent of which a construct is truly distinct from other constructs by empirical standards. Discriminant validity assesses again the extent of which construct is different from other construct and is a vital aspect of construct validity. The HTMT is more conservative criterion when assessing discriminant validity. The value of the HTMT showed by less than 1 but more restrictive thresholds such as 0.85 or 0.90 are often used. If the HTMT value is above this threshold, it actually indicates a lack of discriminant validity, and then it will suggest that the construct may not be distinct and could be measuring similar phenomena. Now, for instance, in a model where we have constructs like customer satisfaction and customer loyalty, we would expect this construct to be related but distinct. If the HTMT value between these two constructs is above the chosen threshold, for example 0.85 or 0.90, we could infer that this construct might be too closely related and could be measuring similar aspect of the customer perspective, which would also suggest a lack of discriminant validity. Therefore, in sum, or in conclusion, the HTMT is a useful tool to ascertain the discriminant validity of construct in our model. Now, finally, if we look at the table for this assignment, what are some of the findings? Now, the table on the slide shows that the result of the discriminant validity analysis using HTMT ratio. Now, it shows that the HTMT value for assurance to empathy, assurance to reliability, and assurance to responsiveness are 0.749, 0.74, and 0.845 respectively. These values suggest that assurance has moderate to string discriminant validity from this construct. The HTMT value for reliability to responsiveness, reliability to satisfaction, and reliability to student loyalty are 0.883, 0.518, and 0.613 respectively. Now, these values suggest that reliability has moderate to strong discriminant validity from this construct. The HTMT value for responsiveness to satisfaction, responsiveness to student loyalty, and responsiveness to tangibility are 0.439, 0.606, and 0.764 respectively. Now, these value for responsiveness indicates that responsiveness has good discriminant validity for this construct. Now, the HTMT value for satisfaction to student loyalty, satisfaction to tangibility are 0.634 and 0.535 respectively. Now, these values suggest that satisfaction has good discriminant validity from this construct. And finally, the HTMT value for student loyalty to tangibility is actually 0.702. Now, this indicates a good discriminant validity between these constructs. Now, I have actually reached the end of my presentation. I hope that it has given you, Doctor, a good picture of the analysis that has been done, and also display a bit of what I've learned and my understanding of some of the analysis that has been required to be conducted throughout this assignment. And again, I want to take this opportunity, Doctor, to say thank you very much to you for giving me the opportunity to learn and expose myself more to SmartPLS. I didn't have exposure to SmartPLS before this course, but having done this subject, on top of SPSS, which I was more familiar, I had the opportunity to learn more and to kind of experiment and do a lot of analysis from SmartPLS, which I believe will be extremely valuable as I move forward for my DBA program. So with that, Doctor, I would like to thank you once again. Assalamualaikum warahmatullahi wabarakatuh.